Lesson 312, rewriting expressions and equations. So we're going back to fractions today. Today you're going to simplify complex fractions and use substitution to simplify and factor algebraic expressions. So lots and lots of algebra and manipulating fractions today. So you might have heard the expression, don't judge a book by its cover. When you look at different expressions today, they might appear complicated, but we can simplify them. We'll work through it together. We're looking for properties of exponents, substitution, and the giant 1. So a fraction is a complex fraction when the numerator and or the denominator also contain fractions. So now we've got fractions inside of fractions. Mind blown. So taking a look at these, we got to figure out what on earth can we do to simplify these fractions. One of the things that I can do is multiply by a big 1. So if I start to look for common denominators, 3x squared and x squared and 1 all have a common denominator of 3x squared. So I can multiply the numerator and the denominator by 3x squared. I'm multiplying by a big 1. So that gives me 3x squared over x minus 15x squared over 3x squared divided by 24x squared over x squared plus 18x squared. So it looks like I just made this more complicated, but now I can go through and see what's going to cancel each other out. 3x squared divided by x simplifies to be 3x. 15x squared divided by 3x squared simplifies to be 5. Oh, sorry. That's a 12. Twenty-four x squared divided by x squared simplifies to be 24. 18x squared divided by 1 is 18x squared. So now I don't have fractions in my numerator and denominator anymore. So I've simplified it. You're done simplifying when you've gotten rid of the complex fractions. So looking at problem B, when you have negative exponents, I would rewrite those as fractions. So I have 1 over x in the numerator plus 8, and x plus 1 over y squared in the denominator. So I look at what all the denominators have in common. So x and a 1 and a y squared. So my common denominator is xy squared. And I can always multiply by a big 1. So I can multiply the numerator and the denominator by xy squared. So I'm left with xy squared divided by x plus 8xy squared divided by 1 all over x squared y squared divided by 1 plus xy squared divided by y squared. So again, it looks like we just made it a whole lot more complicated, but you can simplify each one of those fractions. So the x's are going to cancel out. And in the denominator, the y squareds are going to cancel out. So I'm left with a simplified fraction. So using substitution is another way to simplify. If you're going to attempt to factor this, and Anne thinks that the exponents are confusing. So her teammate Eaton suggests rewriting the expression to make it look easier. So replacing this x to the 6th with u squared and replacing x cubed with u is equal to x cubed. So now it's easier to factor because I just have a quadratic. So I have 3u plus 2 times 3u minus 1. So now if I go back and I replace that u with x cubed, because I said in the beginning that u was equal to x cubed, I have 3x cubed plus 2 times 3x cubed minus 1. So you can simplify to make your problem easier in the beginning and then just replace that substitution at the end. U is a really common traditional symbol used for substitution. If you want to make more substitutions, you can pick different letters. And there's nothing special about the letter U. It's just traditionally been used for substitution. So for problem 23, if you're going to use substitution to simplify these, first decide what U should equal. So what makes this problem look complicated? That cosine value. So I'm going to say that U is equal to the cosine of x. So I can rewrite this as 5u squared minus 9u minus 2. Now I've got an easy quadratic to factor. 5u plus 1 times u minus 2. And then my last step is to go back in and replace whatever I substituted for u. So my final factored form would be 5 times the cosine of x plus 1 and cosine of x minus 2. For problem B, I would make u equal to 4x minus 1. So I'm left with u squared plus 12u plus 20. Now I've got a simple quadratic to factor. U plus 10 times u plus 2. So plugging in my value for u, I have 4x minus 1 plus 10 and 4x minus 1 plus 2, which simplifies to be 4x plus 9 times 4x plus 1. I can continue to use u substitution for rational exponents also. So what makes this look complicated is the 7 to the x power. So I'm going to substitute and make u equal to 7 to the x power. So I'm left with u squared plus 4u minus 12. That looks like a much more simple problem to factor. So I have u plus 6 times u minus 2. Substituting for u, I'm left with 7 to the x power plus 6 and 7 to the x power minus 2. Last one of these, take a look and see what makes the problem look complicated. That x to the 4/3 power. So substitute u for x to the 4/3 power. So you're left with 4u squared plus 11u plus 6. Factoring that to be 4u plus 3 times u plus 2. And then substituting back in for the u, I have 4x to the 4/3 power plus 3 and x to the 4/3 power plus 2. So if I want to use substitution to help solve this problem, I'm going to make u equal to the sine of theta. So I have 2u squared plus u minus 1, which simplifies or factors to be 2u minus 1 times u plus 1. So u is equal to 1/2, or u is equal to -1. So substituting my sine value back in, I've got my solutions for u, but now I need to solve for theta. So this is saying that the sine of theta is equal to 1/2, and the sine of theta is equal to -1. So I have to think back to my unit circle and see where is the sine value equal to 1/2. At pi over 6. And over here at 5 pi over 6. So sine of theta is equal to 1/2 at pi over 6 and 5 pi over 6. And where is the sine of theta equal to -1? Down here at 3 pi over 2. So the sine of theta is equal to -1 at 3 pi over 2 on the unit circle. Homework problems for this section. Please complete those and turn them into Canvas.